Hello everyone, welcome to 5 Minutes Practical Programming Tools. For this video, we continue to discuss about the VTK. I think the contents for this video is a little bit interesting since it comes from a real use case. I received an email several days ago. In this email, we have the grid, which is 100 times 100 times 1. And we want to generate the new grid based on original one. The new mesh type is the new mesh size is 100 times 100 times 3 or times 5. I will show you how I do this by using Paraview, and I will also show you how to use the transform and group filter in Paraview. Besides, I think it is also important to introduce the unstructured data representation, which is a really important and fundamental data representation in VTK data format. Okay, let's start with our demo. Okay, let's load the data firstly. Hit this and load this data, hit apply. We could go through the information and properties for this data. This data is an unstructured grid, which contains those number of cells and points, and there are several attributes. For the property, we could color the attributes, different views. Currently, our task is to add several layers based on the original layer. What should we do? Intuitively, we just need to modify the z coordinates, for example, +1 or 2 for all the points of the mesh, and then we could transfer it. Paraview has already provided the transfer filter. We just need to hit filters alphabetic, load it again. Filters alphabetic, apply first. Alphabetic and transform. These are all different filters provided by Paraview. Before you write your own code, just go through those filters to say if it is available, it is okay for your case. Hit transform and apply. So here, translate, rotate, and scale. For this case, we could hit 1 firstly, and apply. If we show those two layers, we could say this is original layer and this is transformed layer. And how to group them together? If we want to add more layers here, I could load this data several times. For this one, I could add a transform. This one I will cite the number as 2 and apply. Load the data again, apply. Hit the right button, add filter. You could get that one from the recent. Transform 3. Hit apply. Yeah. Then we want to group them together. It is a little bit tricky to use the group at the first time, but it is really convenient. The important thing is to hit the control button, control key. When you click this output, just hit the control, and you could choose several different output, and then hit this. This is the filter of group datasets. And then hit apply. By this way, we could get a grouped datasets. And then we could save the data. For example, group test. There are and if we load this data, group test, apply. So here, there are several layers, and for this multi-block data set, it contains 3 separate unstructured grade, and we could say there are different blocks. Yeah, here, different VTK block color, and the temperature, pressure. Another way to group data is to use the append filter, append dataset and append attribute. I could show you how to do that. Similarly, we hit the control and choose those three filters, 3 output dataset and filter alphabetic append datasets, and hit apply and save data. Oh, sorry. Save data. Okay. And then we could load this data aggregate 4. Yeah, this is data we output just now. So here, this is a grouped data. It is different with the group data sets. For this one, there is only one data set. Yeah. And those 3 layers are combined or are merged into one data set. But for previous one, it contains 3 different layers, 3 different data sets. We could show different field here. So by those append data sets and by this group data sets, we could group our data set conveniently. The important thing is to hit the control button to include different input and the different data sets. Okay, let's introduce the unstructured grid for VTK briefly. This is a topology for unstructured grid. It could construct different type of mesh. For this paragraph, the unstructured grid is the most general form of dataset in the unstructured grid. Both the topology and geometry are completely unstructured, and cell type can be combined in arbitrary combinations in an unstructured grid. It is really flexible, and we call that explicit representation. Although it is flexible, it is also inefficient for memory using. Let's say our original dataset. This is the dataset we used just now. If we search this keyword data array, for first one, this is our field data, and for this one, it's another field data pressure, and another one is temperature. It is also field data. This one is important, points. Basically, it is the coordinates for every points in our mesh. If we show this, it is a specific mesh data. For example, if you view it by points, we could say there are different points here, and The coordinates of the points is labeled by this array, and it tells us that number of components is 3. So so every point is labeled by 3 numbers. And another is connectivity. What does connectivity mean? It means how could we construct a specific cells? We go through this picture. This picture shows the connectivity for different topology. For example, if we want to express this voxel, the connectivity is 0, 1, 2, 3, 4, 5, 6, 7. I mean, this number as numbers as an index for specific points. For our data, those are the indexes. I mean, if we combine them together, I mean, the VTK will show the data by this thing, by this format. I mean, those 8 numbers. Those 8 numbers will group into one specific topology. For other data array, this is offside. It means you could say that the difference for 2 numbers is 8, which means every cell is a voxel. Another is types. Why it is 12? I mean, all the value is 12. If you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it means every cell is this topology. So that's why all elements are 12. Okay, that's cell side, but actually it is not efficient to express the data by the explicit expression for this data set. If we go through this, actually, if we express it by VTK, by the image data, it might be more efficient. In that case, we just need to image data, 3-dimensional image data. We just need to label the lower bound and the upper bound. It is also efficient to modify the dataset. And I also list some references here. For the first one is a filter list of Paraview. And the second one is a discussion. I mean, if you have some questions or problems for using Paraview, you could always post your questions here. They will reply quickly. Okay, thanks for watching. See you next time.